Okay, guys, this is part two on the math. Um, this ACT practice test two is from the ACT official website. It's the new enhanced test. I think it's the same exact as the digital version that they offer online. They also offer PDF version. I got it from here. If you look at the link here, act.org. If you click on this one, ACT practice test two PDF is where I got it. Um, I think that it's the same as if you go down here to full length practice test for the enhanced digital version, I think it's the same as this practice test to mathematics that you could take time or untimed. So I think that's the same thing, but I know how I access this was through here, through the ATT official website. Okay, without further ado, let's continue. This is part two of the math video. I think the last one we left off on was 33 was the last one we completed. 32 was the last one we completed. 33. The roots of a polynomial equation are 0, 2, and -5. Which of the following is a factored form of the equation? So if the roots meaning solutions, the way you write them in factor form is you write the opposite. The x turns into just x. The 2 in factor term turns into x minus 2. And the -5 in factor term turns into x plus 5. And you said that equal to 0. This is the factor form that would have those as roots or solutions. Because if you set x equal to 0, you would get obviously 0. If you set x minus 2 equal to 0 and you solved, right? You said x minus 2 equals 0, and you solve this equation for x, you would add 2 to both sides, right? And you would get what? You would get x equal to, same thing if you said x plus 5 equals 0, and you solved it, you would get x equal to -5. So this is how you write the factor form of those roots, which I think is choice B. Choice B. Make sure you include the 0, because sometimes people might forget that that's the x on the outside. Excuse me, got a little cold. With number 34, it says if 3x minus y is equal over x plus y is equal to 508, then x over y equals. So this looks a little bit confusing when you look at it as is. Um, but the way that you can do it would be if you um, get x, get y by itself, and then do x over y. I'll show you. This is how I do it. There may be another way to do it. So whenever I see a fraction, first thing I'm thinking is what? Cross, can't cross multiply. When I see a proportion, I'm sorry, one fraction equal to another. So I'm going to do 8 times 3x minus y is equal to 5 times x plus y. Okay? So I diagonally multiply, right? Now I'm going to what? I'm going to distribute, right? So 8 times 3x is 20, whoops, 24x. 8 times -y is minus 8y is equal to 5x plus 5y. Just distribute it. Okay, now I'm going to put the x's on one side together and the y's on the other side. So I'm going to subtract 5x from there. That's going to move that over there. And then I'm going to add 8y, cancels over here. That's going to move the 8y over to this side. So I move the y's to that side, move the x's to that side. Once I do that, I get 24x minus 5 would be 19x equals 5y plus 8y is 13y. Now I'm almost ready for x over y. Well, actually, I have x over y. All I do is what? I divide both sides by y. Um, do I divide by 13 first? No, I divide both sides by y, right? So y, 13y divided by y is on that side, it's over there, but and look what I have. I have almost x over y. I'll finish it up over here. I have 19x, whoops. I have 19x over y is equal to 13. I have my x over y that I'm looking for, but I just have to get rid of my 19 on top. How do I get rid of that? I could do it by multiplying by 1 over 19, which is the same thing as dividing by what? 19. So if I multiply both sides by 1 over 19, this 19 is gone. And whatever I do to one side, I do to the other. So it was 19 times x over y. I can just divide by 19. That's the same thing as multiplying by 1 over 19, by the way. And what I get is now I got x over y by itself, which is what I wanted there. That's the same thing as here. And that's equal to what? 13 over 19, which is choice G. So that was just algebra manipulation. 35, let the slope of 3x plus 2y equal 5 be m1, and the slope of 6x plus 4y equals 7 be m2, which the following is true. And so you have to compare the slopes. So how do I get the slope of an equation? Well, first, of a linear equation, it has x and y. I have to get what? Y by itself, because y equals mx plus b. They call it a slope-intercept form of an equation of a line. Y equals mx plus b. Once you get y by itself, the coefficient of x is called m, which is the slope. So I had to get both of those equations like that. So I'm going to do the first one. I'm going to get y by itself so I can see the slopes. I'm going to subtract 3x first step. I'm going to put the x term first. I don't have to do that, but I'm going to do that. So instead of doing, well, I turn next to 5 minus 3x. I'm going to switch these around. So I'm going to do 2y is equal to negative 3x positive 5 plus 5. I just want to put it in mx plus before the x first. Don't have to do that, but and then I'm going to divide both sides by 2. Now, when I divide by 2 here, I'm dividing both sides by 2, which really means I'm dividing both the negative 3 and the 5 by 2. So I have y is equal to negative 3x over 2. Now, remember, I'm dividing the whole thing by 2, so I can divide both plus 5 over 2. So my slope for my first equation is negative 3 over 2. Let's find out what the slope for my second equation was. So I have 6x plus 4y is equal to 7. I'm thinking it's going to be the same. You know why? Because you see how if I do 3x times 2, I get 6x. And if I do 2y times the same 2, I'm going to get 4y. So all I did was a multiple of 2 on the x and the y. So I think they're going to come out the same slopes. But let's just be sure. So I'm going to get y by itself. So I'm going to subtract 6x from both sides on there. I want to do 4y is equal to 7 minus 6x. I can't combine other than that like terms. This is a constant. This is a variable term. I'm going to switch them around. So x is first, negative 6x plus 7. The last step to get y by itself is I'm going to divide both sides by 4, right? And when I divide by 4, what happens? The same thing. Yeah, y equals negative 6x over 4 plus 7 over 4. When I divide, these are two terms, a negative 6x and a plus 7. The plus separates the terms. When I divide the whole right side, I divide both. And then I can reduce negative 6 over 4 to negative 3 over 2 because both 6 and 4 divided by are divisible by 2, or plus 7 over 4. The lines have different y-intercepts, but they have the what? Same slopes. Therefore, M1 would be equal to M2 because M1 is the slope of this line, which is negative 3 over 2, and M2 is the slope of this line, which is also negative 3 over 2. Okay, the piecewise functions of f and g are given. So piecewise means that this f of x would be negative x squared for all x less than 0. So basically all x on the left side of the axis. So if I had for instance, if I had an xy axis, right? My x less than 0 are all my x on the left side of this because all my x less than 0 are my negatives, right? It's negative x squared. So that will look something like this, right? Because negative x squared is the whole thing, right? This is negative x squared, but I'm only concerned with the part of my graph that's less than 0. So it's just that side. And then it says on the right side, when x is greater than or equal to 0, my line should look like 1 minus x, which is basically a line with a y-intercept of 1 and the slope that goes down 1 over 1. So this would be the right side. So the whole line will really be like this. But remember, this piece is restricted to what for x is what? Greater than or equal to 0. That means on the right side. That means I don't want anything on the left side of that. So that's the f of x function of my graph. Okay. The y of x function of my graph, I mean, the g of x is similar, but we may not even need that. So, and I don't think we do. I just want you to get the idea of what piecewise means. So for this function, it says, what is the value of f of g of -1? This is a composite function. We start with the inner, right? We start with the inner. So what is the value of g of -1? So we go to the g function. All right, let's clear all this out. So for g of -1, we go to the g function when it says -1 for x, that's our input, which is this one. When x is less than or equal to -1, which means we're focused on this part of our g function, which means that we use this one. So we plug in for x, we plug in -1 for x. We use this particular equation and we plug it in -1 because that's what the parameter says. It's basically saying use this equation here on what? This equation here when the parameter g, when the x is less than or equal to -1 for your g function. Hope you understand that. I'll say it one more time because it might be confusing. So when we have g of -1, we go to our g function, which is here. And we're saying when the input is -1, the inputs are here, right? So we basically, if the input was less than or equal to -1, which is what we're looking for, we use this equation. If the input were greater than -1, we would use the x minus 3 equation. But that's not the case. Our input is -1. This says when x is less than or equal to -1. So we're going to plug -1 into our input for this equation. Absolute value of -1. Absolute value makes anything positive. That's +1 plus 7 is 8. So we have g of -1 is equal to 8. Now, that means that basically this, so when we do our original function, which was f of g of -1, we know that g of 1 is equal to 8. So this can become f of, you guys see that we just did substitution. We found out what g of 1 was equal to. Whoops, not f of x, f of 8. And so our input is no longer g of -1, it's actually 8 because g of -1 is equal to 8. So we want f of 8. So we have to do the same thing with our f function. I'll change the color. All right, so for f of 8, right, we have to identify when the input is 8. So we have to use this one. Why? Because it says x, well, when x is greater than or equal to 0, 8 is greater than or equal to 0. So we're going to have to use this function. So we're going to do f of 1 minus, and our input is 8. And 1 minus 8 is -7. So that means that what? F of g of 1 is g of -1 is equal to -7. Let f be defined by f of x equals 4x plus 7. Let g be defined by g of x equals -2x squared plus 11x plus 1. The graphs of y equals f of x and y equals g of x intersect at one of the following xy points. Which one? Well, they would intersect means they would meet when you they would have the same x and same y. That means that you can set them equal to each other. If they intersect where the two intersect, that means when you set them, you can set them equal to each other to solve the x. Because intersect means they'll have the same x and y. So that means these y's would be the same, which means you can set them equal to each other. So intersect in this case would mean that what? f of x, f of x is equal to g of x. Because intersect, they would have the same what? X and the same y. And the y is the output. So we want to find the x that makes these two the same. That's why we set them equal to each other. So what is the x that makes them the same? So we say 4x plus 7, that's how f of x is equal to negative 2x squared plus 11x plus 1. If you had a graphing calculator, you could put this one in to y1. You can put this one into y2 and find the point that they meet. That actually would be the easiest way to do this. I could probably pull it up on Desmos calculator. Um, I could probably show you that. I think it's going to show up too. Let's see, Desmos graphing calculator. There we go. It's showing up. All right. So I got the equations. So I'm just going to put them in. So got 4x plus 7. It's graphing that one. And I put enter, and then I do what? Negative 2x to the what? Second power. The way I get to the second power is I could do, there's a way you can plug that in, but if you didn't know that, you would just do the pad and you would do there, right? X to the second power, right? And put this calculator down. I could use the calculator if I want, but I'm just going to type plus 11 uh, x plus 1, right? And so now I'm going to my graph and I want to see where these two equations meet. Oh, and it gives it to me. See that? It's giving me my key points. It's giving me my x-intercept, my y-intercept, both my x-intercepts, my y-intercept, and it's giving me my point of intersection, which is at 1.513. So this is, and then you would have access to, I think you would have access to a graphic calculator when you do it. Um, what was it again? It was 1.513. Let's say you couldn't see it. You could always scroll. You could zoom in, zoom out, right? But 1.513, yeah, when you click on it, it looks like it's hitting it twice though. 215, let's see. Is it hitting it twice? I think it's hitting it twice. Looks like it's hitting it twice. 215, 1.513. Well, let's go to the question to see which one I answered. 215, 1.513. So 1.513. Yeah, I don't know why 215 was hit because I don't think that's one of. But 1.5 is 1.5, 13. So it's B. Okay, that's how you would do it with your graphing calculator. I think you have access to a graphing calculator when you take the test, but let's say you didn't. If you didn't, you would have to solve a quadratic, right? So if you didn't have that, you would have to solve a quadratic. So how would you solve a quadratic? Well, this has a quadratic x squared x to the number. Whenever that's the case, you want to set it equal to 0. So we're going to move the negative 4x and the negative 7 to this side. So I'm going to make sure I put the negative 4x under the 11x like terms. I'm going to make sure I put the negative 7 under plus 1 like terms. So they're gone there. And now I have an equation that's set equal to 0. I have negative 2x squared. 11x minus 4 is plus 7x. 1 minus 7 is negative 6. I can put this in the quadratic formula if I want. You guys would have to know quadratic formula to get. Okay, so one of the following points. So it might have two solutions. It might cross it twice. I could factor it using yeah, factoring is gonna work because the x are gonna be 2 and then 3 over 2, and then I'd have to put it in to get the other to get the y. I don't know if it's an easy way to do it. All right, so we'll do slide and divide. So I'm here, I'm gonna do slide and divide. I'm gonna do Um, but this -2 doesn't allow you really to do sliding the value. You got to change the sign of everything first, because when you do the sliding the value factoring, can't have a negative coefficient of A. It might be easy. Let's just do something with the quadratic form. You have to remember this though too. So you got x equals minus b plus or minus the square root of b squared minus 4ac over 2a. You can do it with the quadratic formula like that. And then you wouldn't have to worry about signs. You would just get the answers. Yeah, that seems like more work. But you can do the quadratic formula if you want. I'm gonna do side and divide, but I'm just gonna try. So first of all, I'm gonna multiply everything by -1 because I don't want a negative coefficient of x. But remember, whatever we do to one side is the other, it's not gonna affect this side because it's 0, right? So I got still 0 here. I got positive 2x squared. I got minus 7x. I got positive 6. Multiply everything by -1 because I want a positive coefficient of x squared. Now I go to my slide and divide. I'm sliding 2 over to 6 means I'm multiplying it. My new quadratic now is x squared minus 7x plus 12. I want the factors of 12 to give me -7. That's going to be -3 and -4. I add those to get -7, multiply them to get positive 12. Therefore, I'm at 0 is equal to x minus 3, x minus 4. Okay, and you would think a lot of people mess up here. I'm done. No, it's called slide and divide. I slid the 2, now I have to divide the 2 by both, right? So I have to divide the 2, divide the 2. Okay, and I get what? I get uh, x minus 3 over 2, and then I get x minus 2, right? Equal to 0. Now, 3 over 2 is a fraction I can't turn into an integer, so I put the 2 in front, right? So I have 0 is equal to 2x minus 3 and then x minus 2. All right, and then my 2x values are, if I set each one of those equal to 0, I got 2x minus 3 equals 0. I add 3 to both sides, 2x equals 3. I divide by 2, x equals 3 over 2. I set x minus 2 equal to 0. I add 2 to both sides, x equals 2. These are my two possible x values, 3 over 2, which is 1.5, and 2. Now, to get the y, I could plug them into either one. It's easier for me to plug them into the f of x, right? So I know my answer is either what? C or B, because 1.5 is the x coordinate for x raised b, which is this answer, and 2 is the one. So how do I do it? I have to plug them in. So I'm gonna do f of 3 over 2. I'm just gonna plug it in the f. That's easy. I could plug them in the f or g and I'll get the same answer, remember, because I set them equal to each other. So that means I'll get the same answer, but I'm gonna plug them in the f so I don't have to deal with this square term. So 3 over 2 plus 7. For the 2 cancel, that's 2. That's going to be 6 plus 7, which is 13. And that's that, right? So when you plug in f of 3 over 2, you get 7. If I plug in f of 2, I get what? 4 times 2 plus 7, which equals 15. And that's not one of my answer choices. So my possible points that they intersect are 3 over 2, 13, and 2, 15, right? 2, 15 is not an answer choice. 3 over 2, 13 is an answer choice for this one. 38, tourism organization randomly selected 100 tourists. Finishing their summer visit to Spain, the organization asked them how many cities they had toured in the country. The table showed the results. Based on these data for the population of tourists that visited Spain during the summer, what is the best estimate of the mean number of cities toured? So this is weighted average, right? Number of cities toured. So you got to multiply these, right? So this is tourists, 10 tourists visited one city, so that's 10 cities. 40 tourists visited two cities, that's 80. 3 cities visit three, 150 tourists visit 3 cities, that's 150, right? And we want the best estimate of the mean number, which is average number of cities toured. So we got to get, if we want the average number of cities toured, we got to get the, so average cities toured will be what? Will be the total cities over total tourists, right? Sum of cities, all the cities visited divided by the tourists, so that would give you the average number of cities per tourist, right? Was the best estimate for the mean number of cities toured, right? Per person, per tourist, right? They're really not telling that, but per tourist. So for your cities, total cities, it looks like you got what? 240, right? Because we did 90 plus 50, that's 240 there. And then for your total tourists, they said it was 100 tourists. So that's 2.4. That's your mean number of cities toured per tourist. So the average tourist went to 2.4 cities. Okay. That's a weight, they call that weighted average. Given that I is the imaginary unit, which of the following numbers is equal to 3 plus 4i squared? This is just FOIL, you just got to know that what? I is equal to square root of -1. Therefore, I squared, if I square the I square the square root, which is -1. That's the key to these problems, knowing I squared is equal to -1. So when we square it, you have to write two of them. That's another thing. A lot of students would mess this up because they would do what? In my estimation, they would just think, oh, I just square this. 49, I square this. So 49 plus 16i, that's how some students would mess it up. They would miss the square. Others might say, oh, I know I got to square the I too. 49 plus 16i squared, right? And then they would turn I squared to -1, so they get 49 plus 16 times -1. And then that would end up being 49 minus 16, which would be 33. And a lot of students would pick that. That's wrong. That's wrong. You can't just square every term. You can't just square each term when you have a plus sign in between. When you have a plus sign in between, you have to do what? Write two of them and FOIL it. Okay. All right. And so you got to do 7 times 7 and 7 times 4i. And then you have to do positive 4i times 7 and positive 4i times positive 4i. Because if you just square each one, you're going to miss the middle term. So once you do that, you get 7 times 7 is 49 plus 7 times positive 4i is positive 28i, right? Then you get plus 4i times 7 is 28i. And you get 4i times 4i, which is 16i squared. Okay. All right. And then we do what? You got 16i squared is equal to -1. We got 28 plus 28, which is 56i, and we have 49. We combine like terms. We combine like terms and we turn I squared to -1. Now, -1, so we get 49 plus 56i plus -16. The like terms are 49 and what? Plus -16, which is 33. And typically you want to put your number first, so because complex numbers, so it's 33 plus 56i. So a lot of people get this wrong because they would just try to square it each term. When there's a plus sign in between two terms and you square it, you have to write it out like we just did. So the answer really is here. Do you see how the test writers are slick and they put A as a possible wrong answer, anticipating your mistakes? And I want to say these are just people, they create tests for a living. This is what they do. You want to make sure you know what you're doing. So that when you score high on these tests, it is a true revelation that you have some really good ability. All right. Okay. The product of two complex numbers, X and Y, is a real number that is rational. Which of the following statements cannot be true? Okay, so this is a vocabulary question, but let's see if we can write this out so we can make it make sense. Product means what? The answer after you multiply. What are we multiplying? Two complex numbers. So what would a complex number look like? It would be a real number and an imaginary. right? It would be a real number and an imaginary. I just made it minus. I could have made it plus. That's a complex number. So we can call this x and this y if we wanted to, right? And when you multiply two complex numbers, they say that you get the product is a real number that is irrational. Okay? A real number that is irrational. So what does that mean? So when we multiply these two, we're not going to get a real number. We're going to get a complex number. We're going to get 2 times 3, because if we got to FOIL it, right? 2 times 3 is 6, plus 2 times negative 4 is negative 8i, plus 6i minus 8i squared. I squared is going to turn into negative 1, right? So we're going to get 6 plus negative 8i plus 6 is negative 2i. And then negative 8, so that's going to be plus 8 plus 6, that's going to be 14 minus 2i, but that's a complex number. Complex meaning it has a what? A real part, the 14, and an imaginary part, the negative 2i. So the question is, when we multiply two complex numbers, x and y, the answer is a real number that is irrational. That means irrational. That means we cannot write it as a fraction, which are our square root, like square root of 2, square root of 3, or pi, are imperfect square roots. So with both x and y are rational, well, we see which of the following statements are we looking for? What cannot be true? F. They both cannot be rational. If you multiply two rational numbers, you will not get irrational numbers. They can both be imaginary if you use square root of 2. The product of x and y could be square root of 2 because square root of 2 is an irrational number. The product of x and y could be negative. You could have what? Negative square root of what? 2. That's an irrational number, right? That's an irrational number. Um, if they both are imaginary, that's possible that you could get a real number that's irrational if you do this. Let me show you how that could happen. So really, you get this through process of elimination. You have to know your vocabulary on this. Okay. So how could we do that so that that G is, they say cannot be so the G is true. So if we did something like, first we had to multiply by the complex conjugate, and then we had to use irrational. What do we want? We want to imagine, wait, if both x and y are imaginary, well, complex does mean imaginary too, because it has I. So we just showed you, oh, but we didn't get an irrational number. So how do we multiply two complex numbers and get an irrational number? Well, you could do it simply by this if you want. You could just do what? Like the square root of maybe 6i times the what? And make this the square root of maybe 7, right? So square root of 6 times square root of, no, that's not gonna work. Mhm. Oh, yeah, that will work. Because if we multiply these two, we get what? Square root of 42 times I squared. And then I squared is negative 1, so square root of 42 times negative 1, which is negative square root of 42. That is a what? That is an irrational number. Because we can't write this as a fraction because it's a, whenever you take the square root of an imperfect square, it's considered an irrational number. So we have a case where we have x and y are both imaginary, square root of 6i, square root of 7i, and when we multiply them, we got a what? We got an irrational number, right? So this can be true. Of course, this can be true because the product of x and y is square root of 2. that is irrational. So that means that is true. The product of x and y is negative. I just showed you the negative two. So yeah, so F is the only one that cannot be true. So, and I showed you an example of when you do x and y times each other that were rational numbers. That means they didn't have those square roots that were imperfect. That was my first example I showed you. And the answer we got was not irrational, right? When I first gave you the first. If you want to, you can rewind the video to go back to that. All right, the real solution of, oh, you know what? Let me check these. Let me check some of these are a little bit hard. 40. Since that was a little bit challenging, 40, let's see if that's F. I'm quite sure it's F. That's the reading score. 40 is F, yes. So just making sure. I would like to double check because I'm doing these as you guys see me doing them, as I'm doing them. I didn't pre-do any of these. All right, the real solution of the equation, 3 to the e of x equals 12 is, so you have to know how to solve a what? An exponential equation. We have 3 to the e of x equals 12. Well, the first thing we're trying to get x by itself. So the first thing I'm going to do is what? I'm going to divide both sides by 3 because 3 is next to it. That means multiply. So I get e of x is equal to 4. Now, how do you get rid of e? The opposite of e is log natural. So we're going to take ln of both sides, right? So we take ln of both sides. Ln cancels out e. We get x is equal to L log natural of 4. You just have to know how to solve equation of e. You got to know that e L log natural cancels out e. That's really the key to this. All right. 42, the figure shows a triangle ABC, a right isosceles triangle inscribed in a circle with center O and radius 10 centimeters. So center O, radius 10 centimeters. What is the length in centimeters of arc AB shown as the thick curved line? All right, so the figure shows triangle ABC, a right isosceles triangle. So a right isosceles, that means this is a 90-degree angle. There's a theorem on that too. Can't remember what it is, but something about if the hypotenuse of a triangle is the diameter, some theories about, I can't remember the theories anyway. And so I write it with center 0 and radius 10. So this is a diameter. That proves this is a diameter. Because if it's a right triangle and hypotenuse passage, and I can't remember, I would have to go back. Anyway, what is the length in centimeters of arc AB? So we need the length of arc AD. So, let's start with center 0. I know arc length will be what? Would be degrees. Uh, Let me see, how can I do that? Oh, okay, okay. All right, so I'm gonna do it this way. There's other ways to do it too. I think it's a theory about this particular triangle. Um, this is 45 and this is 45. How do I know that? Because it's a right, they say it's a right isosceles. So I know this is right means I know 90 degrees. And the angles of a triangle add up to 180. So if I do 90, and these have to be the same because isosceles means that these sides are the same, which means that these two angles are also the same. So I do 90 plus x equals 180, right? So I do 90 plus 2x equals 180. I subtract 90 from both sides. I get 2x equals 90. I divide both sides by 2x is 45. If you went back and check, 90 plus 45 would equal 180. So that means those angles are 45 by the definitions they gave us. Now, next thing, arc measures. So there's inscribed angles theory. Inscribed angle is an angle whose vertex is on the triangle. So angle C, A, no, sorry. ACB from here to here would be considered an inscribed angle because its vertex here is on the circle. The theory is that this angle, 45, is going to be equal to half of the arc it intercepts in degrees, which means that based on inscribed angles, this arc is 90 degrees. Okay, so we know that from A to B, the measure of that arc in degrees is 90 based on inscribed angles. Okay, because this angle is intercepted by this arc. So angle ACB is intercepted by arc AB. And because ACB's vertex is on the circle, the vertex on the circle, we call it inscribed angle. The inscribed angle, ACB, is equal to half of the intercepting arc, the arc that intercepts, which is AB. All right, now, arc length is typically given by, as part of the circumference. So when you talk about the arc length, you're talking about a piece of the circumference. So with the length in centimeters of the arc, it's arc length. So a whole circumference would be the full arc is pi times diameter, but a piece of that would be we call arc length. Just a piece of the arc would be the same pi times d, but the piece would be represented by the degrees that it is of the whole circle, that piece. So this is 90 degrees over 360. That's the piece represented. The full circle measure is 360. A piece is 90. So this arc of 90 degrees represents, this arc of 90 degrees is 90 degrees out of a whole arc of 360. And you can convert the length of the arc based on that same kind of proportion of 90 out of 360, or the same ratio. All right, so the radius is 10, which means that if the radius is 10, then the diameter is 20, because we know that double radius for the diameter. So your radius is 10, we do another radius, that's the whole diameter, that's 20. So we do pi times 20 times that's times 20, and 90 over 360 reduces to 1/4. And 20 times 1/4 is 5, so that's going to be 5 pi. That is the measure of the arc from A to B. '43, it took Sam X minutes to bike the D miles from home to work. Returning home on the same route, it took Sam Y minutes. On the way home, his average speed was 2 times his average speed on the way to work. So the way home, his average speed was twice his average speed. So that means he went home faster, which means it took less time. What the following equation gives y in terms of x? I think it's going to be an inverse relationship. Maybe not. Okay, what is x? X is the minutes to bike the D miles from home to work. Oh, so if he travels twice as fast going back home, y minutes. So for instance, let's just make up numbers. Sometimes making up numbers helps to get this right. So let's make up an even number. Like let's say it took him 40 minutes. We don't know, but we're just using numbers, right? Let's say it took Sam X 40 minutes to go to uh, work. And then he returned home on the same route. It took Sam Y minutes. We don't know. But if on the way home, his average speed was 2 times his average speed on the way to work. So if he went twice as fast, the time should be half as less. Do you follow? Right? So how do we know that? So let's say he was going maybe what's a good bike speed? I don't know. Let's say 10 minutes per mile. Or no, 10 miles per, no, that would be crazy. 10 miles per minute. I'm not gonna go 10 miles in a minute. Maybe let's say 2 miles per minute. So you'll say your speed that he was traveling was 2 miles per minute, right? So if he went 2 miles per minute, that means that his distance would be 80 miles, right? Because he went 40 minutes, 2 miles per minute. That means that the distance was 80 miles. But remember, it's the same distance going back. It's the same 80 miles. So what would the speed be? The speed would be, um, what? This you're not supposed to know. So if he did, if the distance is 80 miles, remember, going and coming back is the same distance. That doesn't change, right? Because it says he took the same route back. They did in 1 minute, but they said on his way back, his average speed was 2 times his average speed away. So if he did 2 miles per minute going, that means he did 4 miles per minute going back. That's double the speed because he was doing double the miles in the same minute. That's a double the speed. So if he did 80 miles was his distance, then you would do what? Distance equals what? Rate over time. Or we want to figure out the time, right? Because minutes, your formula distance equals rate over time. But if you want to find out the time, you multiply both sides by the time and divide by the R. So you could turn this equation to time equals distance over rate, right? So your distance in this case was 80 miles. Your rate was 4 miles per minute. Therefore, your time would be 20 minutes, which I kind of knew anyway. So if you double your speed, your time should go down half. It just makes sense if you think about it. So that means that y is equal to half of x, which is what I said initially, but I just want you guys to see. A lot of A and F's this time. All right. How many more we got? Two? Okay, good. All right. The hyperbolas here, they're getting hard on us, huh? Towards the end, that's what they usually do. Da 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 da. Graph from the standard coordinate plane, which of the following equations is an ellipse that intersects all four vertices of the hyperbolas. So let's draw what that would look like. The ellipse would look like. It would look like it's not going to be the perfect ellipse, but it's going to look like it's going to be an oval that looks like this. So first thing is the center. First of all, this is not going to be J. J is the equation of a circle, not an ellipse, because ellipses will be over. There would be fractions to begin. So F, G, and H are all equations of ellipses. J is the equation of a circle. All right, so that's not, J is just not right. You just have to I just know what the equation of ellipse and the equation of a circle. What J looks like equation of a circle. F, G, and J all look like equation of ellipses because ellipses are all fractions plus another fraction. Okay. The next thing is to see your how your X's and your Y's are. So if you look at the distance from here to the center and from here to the center, you'll see that the distance from along the X is smaller than the distance along the Y. So we know that the value underneath the X should be smaller than the value underneath the Y. So F is a possibility, and that's it. All the other ones, the Y is a smaller value. This value gives an indication, it's 3 squared, gives an indication of distances, right? So the regular equation of ellipse is x squared over um, x squared over a squared. Well, in this case, a is supposed to be the bigger one. So we see that along the y is the bigger. So this would be b squared as well, but a squared equals 1. It doesn't really matter as much, but they usually say a is the bigger one. That comes when you're trying to deal with foci and what's the other one? The foci and the directrix. Is it directrix? I think that's right. Foci, however you say it. Foci. I don't know how to say it properly, but I know how to do it, but they're not asking for that, so don't worry about that. All right, so but we see along the X is shorter, right? So that's why the B is there and the A is along the Y. But anyway, so in this one, this would be X squared. Whoops. This would be X squared over 3 squared plus Y squared over 6 squared, which means that the distance along the X from the center would be 3 there and 3 there and 6 there and 6 there. That's what the picture shows us. It shows us that these distances from the center to X, the X vertices there, are smaller than the distance on the Y's. So that's why I knew it was F based on looking at the picture. Um, G with G and H all show that the distances along the X's are bigger than distance on the Y. Let's see if we can confirm this too. So let's look at our initial parabolas. So when it was x squared, when it was minus y squared, then this would be 3 and 4. Wait a minute. Okay, because when the y squared is first, I think that's along the y. I think that's this one. So you would have to make a box. So along the y, this would be 6, and this would be 6. That's this one. And along the x, this would be 5. This would be 5. So when you do the lines, but that wouldn't be 5 along the x though. And this would be, so if this was 6 and this was 5, that would be bigger than that. That would be probably like there. This might be 5, that might be 5. So then what you would do is you would draw your rectangle, and then your you would go to there, and that's how you would draw those parabolas. And then you would do the same thing on the x. So this would be 9, right? So this would be 3, this would be 3, then 2. Because this is 4, this is the 4, that's 2 squared. So 2 would be smaller, maybe up here than up here. And then you would draw your rectangles. And then you would draw your lines there. And that would allow you to do that. Um, so yeah, so because the y squared minus the y squared, that means that the parabolas are going up and down. And on this one, it's x squared minus, that means the parabolas are going left and right. Let me make sure that's right. Let me check that out really quickly. Equation graphs of hyperbolas. Did I do that yet? Actually? Yeah. I'm saying graphs of hyperbolas, not hyperbolics. So I think that is hyper. There we go. That's what we're looking for. U-shaped curves. Right, see, okay, and they're showing us there now what we were interested in. So horizontal, see, yeah, that was horizontal. That means going sideways, doing the x squared minus the y squared. That's how I had that right. The vertical up and downwards, or the y squared minus the x squared. Yeah, yeah, yeah. Okay. Let's see if that's right too. Did it get the equation? What's the equation? Maybe just trying to find the horizontal parabolas. Horizontal parabolas, right? Yeah, yeah, I thought so. Okay, yeah, I was right. Anyway, yeah. All right, and then the last one, uh, 45. Given that f of x is equal to the cube root of 2x minus 1, which of the following expressions is the inverse? So, no problem. Inverse function. So first you write y equals cube root 2x minus 1. That's the first step. And then to do the inverse, you switch the x and the y and solve for y. So it becomes the x is here, the y is here, right? You switch them around. Cube root 2y minus 1. And now we have to solve for y. Okay. Change the color when we solve. Do that. Sorry. Okay, so how do we get rid of cube root? We take some to the third power, right? Oh, what's that? Yeah. Yes, thank you, right? All right, so we do the cube, get rid of cube root. Now it's an x way up. So now we got x cubed is equal to 2y minus 1. Then we do what? We add 1 to both sides. We get x cubed plus 1 is equal to 2y. We divide both sides by 2. So we get x cubed plus 1 over 2 is equal to 1. There we go. All right, that is it for the math. 2 parts. Hope this was helpful to anybody. I know you guys can do this with AI and put it in, but sometimes it's easy to see somebody do a video step by step. So they visually right now talking, because I know AI will give you the steps, but it's no voice and it's no visual. So it's just showing you the printed version of the steps. So some math students can follow that no problem. Some need to be moving in visual, and that's hopefully what this provides to you.